All right. So we are back, and we are now going to be constructing our bill of materials, which is very exciting. Very, very exciting. And so if we go in here, I thought I put a good description of what it is, but apparently I didn't. Our first bill of materials does a couple things for us, and we're kind of getting now into this is how Ben does it. So when I say I don't think necessarily everybody would jump into this. I've learned to jump into this because of projects I've done before. And not doing this step really bit me in the butt because I got all the design, all the CAD work done, and then I went to go get it fabricated, and the parts I needed weren't on the shelf. And that was, to me, at that moment, very disastrous because I didn't know how to solder. And that's going to be just about everybody's position that's watching this. I think all of you will probably not know how to solder PCB. You probably know how to solder wires into pinholes and maybe even solder wires together and do some of the bigger soldering. When it comes down to surface mount components, most of us do not know how to do it. And if you do, I am very happy for you. Congratulations. And it's a good thing to learn. But at this stage, I'm betting on most people don't know how. So we're going to have the fab shops do it. In this case, that would be JLC PCB. So in order to do this properly, we want to make sure we have our first pass of the bill of materials. Now, why do we call it a first bill of materials? I'm not expecting to capture every component we need here, but I want to get the main stuff down. So let's go ahead and make a new spreadsheet. That's always the nice way to go. And you know what? I almost want to do it. How do I want to do this? I'm thinking what I want to do is I want to do this in the KiCad project. So we're going to boot up. Remind me later. Sorry, KiCad wants to update. So we're going to make a new KiCad project for the first time. And I guess now we're kind of getting into KiCad, so I should slow down. The reason I'm pivoting over here right now is because I don't want to make this bill of materials be living somewhere else other than where my KiCad project is. So we're going to set up our KiCad project. And I think what I want to call, just going to put a folder in here for now, we'll just call it routing. The training board, but it's a routing board. So we're going to save it into here. I don't want to create a new folder for the project. I just want to go in that. Happy? Yeah. Let's make sure that's living where I'm assuming it is. And so when you make a KiCad project, as we have done here, a couple files are created. So you get the, I wish they have the extensions on here. I remember how to do that. Don't know if I do. Quick, sketches, file explorer. I don't know why I didn't have this configured before. Click on view, file extensions box. There they are. Sweet. Okay. That's a helpful thing. I think I like having these on. I don't know why I didn't have it by default. This is a new Windows installation, but this kind of, now I can talk about the type of files. So KiCad at its default, has three types of files. The first one is your project file, .kicad underscore proj or pro. This is I would call it the entry point. So you'll notice when you open KiCad, this PRO file goes from being a file amongst the other ones to the folder almost. So if you want to open your KiCad, and the data that comes with it, so I think this is the biggest one. A lot of your settings and essentially how you configure your project is going to be wrapped up in this file. There's no CAD in here, there's no design, but it's just your environmental setup. Your KiCad underscore SCH is your schematic file. That is going to be this one right here. And we've already seen that a little bit in this video. This is your blueprint, right? This is where you're not worried about where you're physically placing everything. You're more worried about how you're hooking it up and how you're wiring it. And you always start here 10 times. I am almost willing to say 10 times out of 10 when you're designing a board like this. So that's your SCH. And then you also have your PCB. And that's going to be your actual CAD layer. It looks kind of similar in a way. If it's going to actually show me a board or not, it is. But this is the layer that's going to translate our design to a real printed circuit board. So as you can see right now, this PCB sucks because there's nothing on it. That's super thick. I don't even know if they make them that thick. So right now, we're not in the CAD stage. And you'll notice that KiCad will make a lot of temp files that pop up a lot. I think after this video, we'll set up our GitHub connection. I didn't forget about that. And we'll make a .git ignore that kind of cleans up all these temp files that we will not need, so you don't accidentally push them to your GitHub. But where we are even starting, it's not even in KiCad. We are actually making I really know. So on this, there should be. I always thought it came native, but apparently it's funny. I even have Microsoft Excel installed. So all that just to say that we're still going to go. Well, let me have it running in the background. That's how you know this is fresh. I don't even have Microsoft Excel on this computer. That's why. Oh, duh. Thanks, Microsoft. Okay. Google Sheets it is. Let me get the. Yes. So let's go ahead and go to Google Sheets. All that, just get back to Google Sheets. That's all right. Now, can I? Yes. While I do that, I'm gonna get my ability to actually use spreadsheets locally. So when I download this, it works. But for now, we're good. So first bill of materials, which from here on out you'll referred to as the BOM. We want to track a couple things with this. We want to track the name of component. We want to track the manufacturer. We want to track the not even the quantity at this point, now that I think about it. Or like I don't know. We need the length. And I think this, let's see, just forget, is that the word right now? But actually, it does show up on that. This is a JLC PCB thing. This guy. Oh, I thought they gave it. Okay. So, and then probably purpose. So, I like having a field that kind of explains, well, this is why I have this in the first place, you know. So this is one piece we already know we want. This is that current monitor. From Texas Instruments. You in though as a link. I usually put my links end because they take a lot with LCSC. This is a number. This is how we're going to identify the GLC PCB. This is what we actually want. This will make sense later. For now, we're just going to grab it. And then the purpose, current / power monitoring board. Okay. So we know we need that. That one we kind of figured out in the design stage. We're going to need a switch. Oh, that's right. This what we had. This was the power scheme we had decided upon. Just trying to rewrap my head around it. 2 potential power sources, which would also just be coming from there. So we can switch between, which this most likely is that. So I can switch between the 2. Which I know. I gotta think about where we're plugging that monitor. For now, I know I need this regulator. I think this was a must. Yeah. Yeah, this was a must. So this AMS 117-3.3. AMS 7 dash. And if you remember what this was, this is the LDO, dropout, linear dropout regulator. This guy is pretty important just for, I mean, I'm pretty sure I explained it in the previous video, but essentially lets us step down the voltage for cheap. We don't have to have any fancy programming or anything. We can just go power in and get a different voltage out. Let's see if there's any. This is something to know about JLC PCB. Everything is way cheaper if it's a basic part. So a lot of times I like to toggle that. As you can see, this one is. And that's the reasoning for that is they charge you an extra $3 for every single extended part, non-basic part you have. So we prefer to have the basic parts. This one on there. Advanced Monolithic Systems makes it. I don't mind this like boom, boom. This is LDO board to get 5 volt and 3.5 have that. So those are 2 main pieces we've already figured out. There were a couple more I had in here that I had kind of figured out a while ago. Sensors, processors, and storage. So sensors we have, we're going to need the processors and we're going to need the storage. Part of the reason I guess I added the logging was so I could teach you guys some STM stuff. It took a little bit for me to learn it, but now that I've learned it, I feel a lot more comfortable with it. And the STMs are MCUs, which are microcontroller units. And microcontroller units are going to let you essentially build your own Arduino, which is very fun. We're going to do that here in a much more reduced capacity. With that being said, we're going to need two things. We need storage capabilities and we need that MCU. But now I got to think. I think storage wise, I want to use. I didn't ask Gemini today. I2C storage. Know of NAND and micro SD. Micro SD, I don't think I want to use. It saps a lot of power and it's a lot more fragile. I think I want to use I2C NAND. And I guess technically micro SD isn't even I2C. Because micro SD is going to use SPI. And I guess NAND uses SPI as well. EEPROM. Yep, I've heard of that. Most common I2C storage. 2 bytes up to 1. FRAM I've heard of. Then I think we want NAND storage. Start with that for now. We'll look up on the parts. Really? Yeah. NAND storage. These are all NAND gates. SPI storage. Nope, not going to do it. Okay. So then I can do raw. That way. That way. I want to know, I kind of want to narrow down my sensors here a little bit. This is something, I do not trust AI to do my design yet, mostly because it's not really put in a loop to a good agentic loop to really do good checking, but I do like to use it to get me kind of looking down the right window here. And I kind of know I wanted to do NAND. That's kind of a thing I knew coming in. I've done micro SD for a long time. I've struggled with it and I've had lots of fits and I want to try something else. So I think I want to look at this. So let's take a look at what this is. Never seen this before. WinBond, huh? And take a gigabyte. That's a pretty good amount of storage. Not 32 like a micro SD, but gigabyte, 3.3 volt, good. That's what our drop down is going to, our LDO will force us to have. This package, 6x8, 6 pins by 8. Never used this package before. So before we get even too deep into the weeds, good, they have it. They're all extended parts, which I expect. So I guess we can even take a look. Oh, good job, guys. GLC's site is being. Take a look at this one, this data sheet. 3 volt, 1 gigabit. 1 gigabit ends up being 1 gigabit to Those are different, aren't they? Yeah. When is it? That, because it's lowercase b. So we're looking at 100 megabytes, right? 125 megabytes. Not great, but it shouldn't be storing a ton of data either. Is that enough? You know, if we think about, I mean, what are we storing here? We're probably storing time, which would be an unsigned int of 32. But I gotta really remember my. It's been a while since I've done this type of thinking in my design work. How much? How many bits? Signed int. Probably 16. Let's say 32. It's probably 32-bit, right? Yeah. So 32 bits. Unsigned int 32 bits. A reading. Let's say how many bits is a float. But that's standard float is 32 bits. So let's assume collecting time, current, wattage, and voltage. All those are 32-bit. We have 32 times. No. 32 times 4. We have 128 bits per right, I guess. Yeah. So then we have 1 million. 128. That means we can do 7,812 writes. Say we do so 7,800. Let's say we aim for 100 seconds. So or maybe 500 seconds. Let's just do 1,000 seconds. So 1,000 seconds. That would be about 8 writes per second for 1,000 seconds. I guess I don't know how many of you track that in your head. Essentially, this is how many bits, how many writes I can fit. So each write is 128. It'll be less than that because I think there's more overhead that's going to go into it. This will probably be CSV, so it'll be a little less, but this is ballparking it. We ballpark at 128 bits to store 3 floats, each at 32 bits, and 1 unsigned 32-bit for time, which might be a overkill to be honest. But and then we have 1,000,000 bits to store on our NAND that we were looking at, and so 1,000,000 divided by 32 times 4 bits gets us 7,800 writes to fill that up. So then I wanted to say, okay, I have this many writes to fill up our thing. What if I ran that for 1,000 seconds? Well, that would be this divided by 1,000, right? Gives us how many writes in a second I can do. I can do just under, under 8 writes per second for 1,000 seconds. Now, are we going to do that? No, because our rest mode is probably not going to need that. But that's how much I can fit in a 1,000-second window. And 1,000 seconds is, 16 minutes. No. Yes, you could sit on the pad for 16 minutes. So that's going to show the importance of really slowing that down and then speeding it up for when you're out there. But I think 1 gigabit will be enough. If not, then we'll redesign another one that's bigger. You know, I mean, that's the beauty of this. You get it wrong the first time, well, we just try again, right? So, um, SPI flash, dual quad SPI. Let's kind of see. I want to kind of take a flyby of this. 8 pins. They're using the new IO. Data out, data in, serial clock, ground, hold input. Yep. That all checks out to me. I think we're not using that one. Getting the 6x8. Yep. So 6x8 is going to be 8 pads 6 millimeters apart. That's what that is, right? Okay. So this package is going to be 8 pads. Each is 6 millimeters spaced out. Pretty simple. I don't have much more to say beyond that, I guess. There's a for sure. This is all pretty right. Protect. Yep, it's important. This is all pretty good, I think. This is just basic SPI. We'll kind of talk about that more when I actually wire it up. 64 pages. Something I need to study up a little bit better on. Main memory array, ECC protected area. Memory is not my strongest suit, but I think this mostly fills what we need. We're gonna run with it. I like it. Wind bond, huh? That's that goes. A wonderful name, right? That number. And then storage. So the STM MCU is kind of the last thing we have to figure out. I may want to get my bearings before I do this, to be honest. How long is this video? 30 minutes. So we're going to stop here. We've got the start of our bill of materials. We've got 2 components we already identified. We've identified our storage. Now we need our MCU, and that's going to be its own standalone thing, so we can really dig into what is on an MCU. So we will talk then. And now, I hope you guys you can feel we're getting close. You know, we even opened KiCad today. Yes, so we're gonna be getting there. And yeah. Anyway, hope you enjoyed this one. I will talk to you next time. Yeah.